All right, welcome back to Daily Maths Concepts. Today, what we're looking at is the number 5 question on our June 2022 Add Math Paper 2. So the question says, determine the integral of 4 cos theta minus 6 sine theta based on what we have here. So we could have 4 cos theta u minus 6 sine theta u. So we actually could split them like that. So basically what we want to do is to think about where would this come from? Because the concept that we're going to be using is that, remember that ddx of cos theta would give minus sine theta, and dx of a sine theta gives cos theta. So we want to use this to think in reverse. So basically, when I'm going to do this integral now, I'm going to ask, where did this come from? Like cos theta. So cos theta came from sine. So this is actually sine. All right. And then where would the minus sign came from? It came from a positive cos. All right. So then this would be plus 6 cos. All right. Theta. And then there's a constant plus c. So that would have been the representation of the idea here. So the integral of 4 cos theta minus 6 sine theta is actually 4 sine theta plus 6 cos theta plus c. All right, let's go to the next question. All right, so with this other question, we're actually dealing with the definite integral of 3 minus x all squared dx, and we're moving from 1 to 2. What I want to do is to rewrite this. So before I do this, I want to clear this up, right? So this is really equal to, let's square this. I'll get 9 minus 6x plus x squared. So this is what I'm actually dealing with right about now. So I want to take the integral of that. So let me rewrite this. So the integral of 9 minus 6x plus x squared dx. So this is what this would have worked out to when it is being expanded. So taking the integral of this, I'm moving from 1 to 2 right there. All right. All right. So let's go. Remember, with the integral, we're adding. So we'd have 9x, and this would have been 6 x squared over 2. And this one would have been x cubed over 3. And remember, we're moving from 1 to 2. So basically, let me just simplify this. So in simplification, I would actually have 9x minus 3x squared plus x to the third over 3. So I'll end up with that. And remember, though, that we're moving from 1 to 2. So what we're going to do now is just to just dropping our intervals here. So 9, and then I'm going to have 2 minus 3x. I'm going to put 2 squared plus 2 to the third over 3. Then behind that, I'll have the 9 with a 1 minus 3 with a 1 squared plus 1 to the third over 3. So definitely, as you could see, we're dropping in these. So let's see what the numbers that we'll get out. This is going to give me 18. 2 2's 4 times negative 3. That's a negative 12. And this is going to give me 8 over 3, which is basically 2 and 2/3, right? So that's basically 2 and 2/3 there at the front. If I continue working up my piece at the front, 18 minus 12 will give me 6. If we really think about that, so 6 plus 2 and 2/3. So this is like, so basically, this is 8 and 2/3. So that's the front part. So this is actually 8 threes, that's 24 and 2. So this part at the front would have given me 26 thirds, right? All right, so we have that. So for the back part here, what we have, the minus sign is there. This is 9. This is minus 3 plus 1/3. We still have our minus. Let's see. 9 minus the 3, that is 6. And then this is 1/3. So we have 6 and 1/3. So basically then we're going minus 6 and 1/3. But 6 and 1/3 could be seen as 6 3 is 18 plus 1. That's 19 thirds. So we actually have a minus 19 thirds. If we subtract 19 minus 26 minus the 19 will give us 7 thirds. So that is our final response there. So we take the integral, put in our limits from 1 to 2, definite integral, and then we'll end up with, as you can see, 7 thirds. All right, let's look at the last one here. We want to determine the area of the region bounded by the curve y is equal to 5x plus 5 plus 5x minus x square, the x-axis, the y-axis, and the line x is equal to 2. All right, so basically, all right, we could drop this to see what it looks like quickly. I could just drop it. So this is what we're actually dealing with. So this is what we're dealing with right about now. This is our thing. So we need to see, remember, they want to see where this here, where we're talking about 2, and here is 2. So we're taking it here, right there. Right here, this is 2. And y-axis is where x is 0. So right here, the x-axis here. So we are actually trying to find this area here. This is what they want us to actually find. All right, so we're going to be finding that area there. So we're going to take the integral and then use from 0 to 2, all right, as our intervals there. So let's go. So the idea here, let's take a look at it again, is that we'll take the integral of that red curve, yeah, because this is the 5 minus 5x minus x squared. That's this here, taking the integral of that. And then from there, we're moving from 0 to 2. Where did the 0 come from? Remember, the y-axis is the same thing as x is equal to 0. And they did give us x is equal to 2. And they did say the x-axis. So we are seeing all of those things coming out here as we take that. So let's go and employ the working out now. All right, so with this, we want to take the integral, right? We want to take the integral of 5 plus 5x minus x squared dx from 0 to 2, all right? And remember, the y-axis is where the y-axis, yeah, is the same thing as x is equal to 0. So these are our margin that we have from x is equal to 0 to x is equal to 2. That's the interval that we're coming from. So let's do the integral now. The integral, we're going to have 5x plus 5x squared over 2 minus x to the third over 3. So here it is. We'll have that from 0 to 2. All right. So basically, that's what we have. We're moving from 0 to 2. So let's take the time to put out what we have now. We could put it here. All right. We could put it here. So we're going to put out 5. We're going to put 2 out front, bigger number, plus 5 over 2. We have 2 there again, square, and then we have minus 2, and that is going to go up to the third over 3. And then after that, I'll definitely put this part in a bracket. It's going to be a 0, so we're going to have 5 And then we have 5, 0 square over 2 minus 0 to the third over 3. And I'm going to close that off. So basically what we're going to do is to put this together. 5 times 2, that is 10. For this part, I will have 2 2's 4 times 5, that's 20 over 2. And then for the back part, I'll definitely have 8 over 3 for that part. If I continue here, all of these responses behind is a 0. So I have 10 plus 10 minus, this is like 2 and 2/3. So basically I have 20 minus 2 and 2/3. So this is going to give me 17 and 1/3 square units, right? Square units. And there it is. We would have gotten that area bounded by these regions that we have. Thank you for watching Daily Maths Concepts, and look out for the next video coming. If you have not yet subscribed, please subscribe, share, and drop a comment. Thank you.